All right, hello everybody. I think we are back. I think we're live here. So I hope you're doing well. I hope you're doing very well. I am live. Yes, awesome. So I'm back here on November 18th of 2024. Studying. I had a little bit of a break over this weekend. I spent some time relaxing after a long work week with my girlfriend and just did some fun things around town. But anyways, I would like to introduce a couple of pickups I got this weekend. So really cool is I got a couple of books. So the first book I got. I got these all secondhand. I found good deals online. They were basically what, like 80 to 90% off retail price. So I got Python Machine Learning. Ooh, by Sebastian Rashka. Um, and yeah, so I'm really excited to get into Python machine learning. But then I also got one more book. I got the Fluent Python book by O'Reilly here, written by Luciano Ramallo. So really big book here, but really exciting and really looking forward to being able to jump into this and learning some more like intermediate Python. So after originally doing the Python crash course, so yeah, we are stepping up our book collection here, our library, and anyways, but we are currently working on the data structures and algorithms book here. We're on page 73 of 770, working on the reinforcement problems of Python after chapter 1. We concluded chapter 1 in the previous streams. And so this one, I'm just doing I'm working on these problems here. So let's go ahead and just keep working on these. Let's go ahead and let the Discord know I'm streaming. All right, cool. I'll let the stream know. The Discord community know that we're streaming here. And yeah, let's do it. Okay, so we're on 1-4 here, so let's go ahead and create a new problem here. R1-1.4 underscore key.py, right? I'm going to create just a doc string here, and I'm going to take 1.4. We'll copy it. So I'm working on this is a repo for people to use as a study module. Okay, so write a short Python function that takes positive integer n, right, and returns the sum of all the squares of all the positive integers smaller than n. Okay, so we have a number n, right? Or okay, so positive integer n. So def um, function. Okay, well, I guess we can't use that word. We need def. My cat is digging through the litter box. Miss Kitty, stop digging. You're being loud. Okay, so I need to warm up my brain here and get into the flow of things. So we're going to take a positive integer n. So we're going to def, I'm just going to say func1, right? And it takes in a positive integer n, right? N is int, right? The absolute value of int, right? Probably wouldn't put it there though. So takes positive integer n and returns the sum of the squares of all the functions. Okay, so Um, so we have n is an integer. So for value range 0 to n minus 1, right? Goes up to n, right? So up to n. So range up to n, we need to vary value in the range up to n. So 0, 1. So if n was 5 in this case, it would be 0, 1, 2, 3, and 4. All the positive integers smaller than n. Return so we'll have to, let's do sum is equal to, or we'll say count, right, is equal to 0 here. For value in range n, we want to return count plus, for every value we want to do count plus equals value. What do we want to do to the value? Well, we want to power 2, right? We want to square it. Okay, and then we want to return count, right? So if we go ahead and run print func 1 of 5, right, or of 2, this should print 1 squared is 1, 2 squared is 4, so it should print 5, right? 1. I'm done. So up to, oh, because it's not including 2. So it'd just be 1, which would be 1. Okay, so if we want 3, this should give us 5. Exactly. Pooh. So right. Okay, so now not all the numbers. So we need to say, like, for absolute value. So it says it takes a positive integer n. So it would be like if n greater than 0, right? We want to do this. Else pass, right? So if we pass in a negative number here, we get none. I don't think it's not like deliberately, I think, wanting this portion, but we have to take that into account because in the problem it does say it. Positive integer n, so n has to be declared positive. In some sense, we could take the absolute value, but then that's going against the declaration of providing n. It doesn't want us to convert it, and returns the sum of the squares of all positive integers smaller than n. So now if we put in 4 here or 3, we should get 5 back still, right? Perfect. So I think that solves that problem. What do I want to call this though? Sum range some square range what happens if you just so if I do like well, I wonder what happens. What if I were to just go like this? Let's go like, let's put 10, 20, let's put 10 here for instance. 285, right? Let's do 5 for actually. So let's clear this out. I want to try or some little arithmetic here. So 30 is the answer for this function with 5. So 0 through 4 sum squared is 30, right? So 1, 2 plus 4 is 5, plus 9 is 14, plus 16 is 30, right? Perfect. Okay. So what if it's 5 squared is 25 plus 5. So I wonder if there's an easier way to write this function actually, rather than saying this is you just square n and add the range value, right? Convert this to an integer value and add it. I think that would provide the same answer. So what happens if I go like this? I def func1, it takes a value of n. I if n greater than 0, right, we want to then do the thing. We want to say count is equal to 0, right? For value in we just want to return n squared plus the int range of n, right? What this I think this does the exact same thing. Now I could be completely wrong here. Now I might be getting way naive. So what if I just print func1 of 5, right? Will this give me 30? Int range n. Okay, so this gives me back an int. Okay, so I don't need to do that. So no. How can I say, so I can't directly do math on this object, right? How to convert I know it. So you just have to define the individual attribute or convert it to a list or sum the range, sum all the values. But I want to use use length. So length would give me right. So if I just say print the range of 5, right? This gives me simply 0 to 5. So print me the length of range 5 would give me the int value of 5. Okay, so that's what I'm needing here. So if we just go, so we need the length of the range of n, right? So now if we do this, we get 30. So does this work? Essentially, I think both of these do the same exact thing, but this one is just way shorter. I've kind of created this uh, function here, mathematical function and function, programmatic function that uh, if you just actually square n and then add all the values from the range below it, you get the same value. It's equal. So let's pass like 100 here, right? And let's pass 100 here. Boom. Oh, wrong. So up until what point would this be false? Because it would start to exponentially curve, whereas this one would be exponential, but it would just not as drastic of a exponential increase. Got you. Okay, so this actually is incorrect way of thinking about it. This has some sort of limitation. At some point, it does not work. It's so by chance, 5 does is within those bounds though. So if I, oh shoot, if I, oh yeah, I change this to 5 and this to 5 and run this, we get 30. So what happens if I just keep increasing this by little by little? Okay, so 5 is the cutoff. 5 is the, if n less than 5, you can do this. Okay. All right. So this is basically this is the answer to this problem. Now let's go ahead. I want to go here. Okay, perfect. Now let me go new problem here. R1.5 underscore key dot pi. Okay, give a single command that computes the sum from exercise R14, relying on Python's comprehensive syntax and built-in sum function. So it wants us to take, just copy this here, and then take this bad boy, bring it over here, right? And so what it wants us to do is a single command that computes the sum so return, we need to return a Python's comprehensive syntax. Mm-hmm. So we need to do comprehensive syntax here. So we want to return we want to return a generator, right? We don't want to return a list. We're just returning a single number. So we're going to return a generator of n times n, right? So we'll square n for for n in range 1 to n, right? N. So we don't want to return a generator. Return n times n for value. Do this. So return n times n, so return the square for every value in the range of n. We want that to be one object, so sum like so. So now I have 5 here, this is going to be 30. Okay, cool. Perfect. So we use a generator to generate a single value here, right? And, or kind of a tuple in this case, right? And we, so just ignore the sum for now. So we want to square n, right? N times n. For every value of n in the range of n, right? So from 0, I could have put a 1 here, 1 to n, right? Because then it wouldn't have to loop through 0, so that would probably be better. So 1 to n value times squared. So then it's going to, rather than just returning a single value each time, we're going to sum each one of those values through this for loop and then return that each one of them. And so that works. So if we put in 6 here, we get 55. If we put in 6 here, we get 55. So that is how you would take this if statement, or this conditional statement, return the sum if, right, we want to say we want to return some, no, we want to get rid of that. if n is greater than 0. So we need to add that because n has to be a positive integer, right? So n, if we did -1 here, we'd get 0. If we did else pass, can you do that? No, it doesn't work like that. So if I put -1 here, I get 0. If I put -100 here, I get 0 still. I thought I should get none. Your function. That's what I thought. Value times value for every value in range that if less. So that returns that. So sum is, this does not need a parenthesis here. So it still gives me 0. Okay, so then if I did 5 here, I should still get 30. Right, yeah, okay. So this one would be, so we want to return value times value, right? This mathematical problem for every value. So we want, for every value, we want to multiply it by itself, value times value, in this range, 1 to n, if n is greater than 0. So n has to be a positive number. We're having this range of 1 to n, which is given here and by the user in this function, and we sum all the values in that range after they're squared, and we do that. So then if we put in like 100 here and run this, we get 328350. We put in 100 into this one, which does the same thing, but without, not in a comprehensive, but in a kind of a normal format here. Same answer. So both do the same thing. Perfect. So we'll print that out, comment that out. Can you add a else pass statement inside? Okay. Cool. Next problem. R 1.6 underscore key pi. Write a short Python function that takes a positive integer n and returns the sum of the square of all the odd positive integers smaller than n. Okay. So this one doesn't seem that hard. It's pretty similar to the previous one. So we want to def func, right, 1 takes in an n in the form of an integer. And then what we're going to do is get a drink here. All right, what we're going to do if n is greater than 0, obviously we're going to do the following. We're going to have a count, right? Okay, we're going to use a count, and then we are going to, for value in range, right, 1 to n, not including n, 1 up to n, smaller than n, for all the values, if value modulo 1 divided by something equal 1. How can we tell if it's odd? Divided by 2. All odd values divided by 2 are not even, right? Yep, right, exactly. So like 3 divided by 2 is 1.5. So if the remainder is not equal to 0, if modulo is 2, right, does not equal 0, meaning that it's odd, we want to count plus equal the value plus equal value squared, right? And then we want to return the value or the count. Right? Perfect. So now, so what this will do is for all the values up to n, starting from 1, so if n was 5, it'd be 1, 2, 3, and 4. If that value divided by 2 does not have a remainder of 0, meaning that it's an odd number, we want to add it to the count, but we want to add not to the value to the count, but the exponent squared value to the count, and then return count. So now, if we run print func1 of, let's do 5, right, this should be different than before, 10. Or if we do print func1 of 3, this should return me 1, this should be 10 as well. No, this should be just 1. 3 is not included. Yes. And then 1 should be just 0. Perfect. So then I need to go into this one here. I don't want to say else pass. I just want to return count. So perfect. So this is sum square odd range. We'll put that here. Perfect. So this will detect if all the odd values up to there. So awesome. And then let's go ahead and move on to R 1.6 or 1.7 underscore key dot pi. Right. So this is going to be similar to before, where we want to use a single function. So I'm going to take this guy from before, bring it over here. And so instead of this, we're going to say return, okay, the sum of value, right, squared for value in range 1 to n if n is greater than 0 and value modulo 2 does not equal 0. And if okay, and value modulo 2 is equal. So let me go back to this one actually. So if value okay, great. So now this should do the same thing. So this should return 10 here. Oh, cool. So now if I do 4, this should include the 3, so this should be 10 as well. And then this should be 1. Boom. Nice. Okay, so what we did was, right, so if n is greater than 0, so if n has to be positive in order for this function to, want to work, to perform this, process. We establish a count variable to keep a running count, or a sum in this case. We know the sum function already does that, but we're not gonna use the sum function right now. We're going to keep a count for the sum for every value that's in this range of 1 up to the integer n they provided. If that value that we're iterating through divided by 2 does not have a remainder of 0, we're going to append or not append, or we're going to just add that value squared times to the count. And then after we get done with all the values in that range, we're just going to return the count value. So and then this one, it's the same exact thing, but in just a one-liner here where we say sum the value squared for every value in this range if the n integer provided is positive, and the value itself that we're iterating through is divided by 2 does not equal have a remainder of 0. So same exact thing, and these both return the same exact function. So if I were to put 100 here, we get 166,650. If I put 100 here, get the same exact answer. So cool. That was 1.6 and 1.7. Hey, Cheese Slice, thanks for joining. You're the first person to chat today. I appreciate you coming in. Sorry about my absence the past few days. Took the weekend to just relax, kind of detox, I guess, and just chill. And now I'm back. But I wanted to, now that you are in here, I wanted to show you. I got a couple of new books. Not new, but they were used, but pretty much brand new. I got Fluent Python, big old thick boy. Fluent Python, and I got Python Machine Learning, not kind of a decent one. So going to be working on these two in the side background. Eventually, as I got a lot of reading to get through, it looks like, but it's all in good fun. But I'm working on these problems here little by little tonight. I'm trying to hopefully get through. My goal is to get through all of the R's tonight, and then maybe from there skip the creatives and the projects. I will come back to them. I don't know. I want to do them though, but it's just taking a lot of time. I kind of want to move on to new concepts, but this is definitely good practice though. So maybe I should stay on this and really, hone it in. Okay, let's do 1.8 here. R 1.8 key. Alright, Python allows negative integers to be used as indices into a sequence, such as a string. If a string has if a string s has length n, the expression sk is used for index negative n is less than k, which is less than 0. If a string has a length n, an expression of string index k is used for indexes of negative n, which is less than or equal to k, which is less than or equal to, which is equivalent to the index j, is greater than or equal to 0, such as that s of j references the same element. If string s has length n, what is this asking me to do? Okay. So Python allows negative integers to be used as indices in a sequence, right? So exactly, if that doesn't seem that difficult. Is it command option Z? Yeah. Okay. So so this is like, say we have string s, right? Just like it says, and this is some string. My name, right? Michael. We can print s of some integer k is used for integers, right? S of 1 would just give me the first one, right? Would give me I, right? Give me I. So if string s has length n, right, and expression s index k is used for indexing that k is negative, right? What is the equivalent index for j such that references the same element. Well, it would just be negative k, wouldn't it? It would simply just be s of negative k, right? If s of k, s index k is used to represent that k is less than 0, which is less than or equal to negative length n, right? What is the equivalent index j is greater than or equal to 0? I just don't get what this is asking me, really. What is the equivalent index j greater than or equal to 0 such that s of j references the same element? String s has length n. Right, n in this case would be 0, 1, 2, or 1, 2, 3, 4, 5, like 7 elements, right? So 7 is n. So negative 7k, which would be like negative up to negative 1, which is less than 0. So yeah, if you can index all the way up to, if you can index up to negative 7, right? Starting from negative 1, right? An index of negative 7 would give me m, right? So you can index up to negative 7. Length n, and expression string index k is used for indexes all the negative indices or the reverse indices. What is the equivalent index that j is greater than 0, or the positive such as that references the same element? Oh, okay, so you just have to mathematically calculate then the inverse of it. So if we're wanting to get negative 7, well, how could we convert that value um, to the positive value? Well, negative 7, right, plus negative 7, which is our negative n, plus, or well, let's do integers first. So negative 7 plus what value would give us to s of 0? Well, we'd have to do 7, right? Equals to 0, which is the first value. So then what would that represent? This would be negative n plus n is equal to k. No, but then would that work for now? We need to incorporate j in here somehow. So where is j? J is the positive integer here. So this is actually j. So then if and this becomes j equals k plus n. Like that, right? If you just carry the n over. So if we print try s of -2, and then s of 7 minus 2, right? Or as of 5 would give me e, right? Okay. So 7 is my j, n minus k is -2. Right. Yeah, I know that these equal the same thing, but right, these equate out to the fifth index, right? So this equals +5, this equals +5. They're both the same thing. 7 is n. Okay, so 7 is up to range n. Okay, so 7 is, okay. So this is n, right? -7 is our j equals n minus k. So why is it j equals n minus k? I got j equals k plus n. So where did I go wrong here? So if I'm wanting the -7th index, so which is the m, or I'd have to add n to that to get to the first one. Okay, so -7 would be my k in this case, right? Plus n would equal my j. Exactly what I got before here. The question is asking what is j positive such that k, sk, and sj where k is negative. Oh yeah, okay, gotcha. Right, so in this case, s would have to be positive, or this one j would have to be positive, or k, sorry, whatever. So yeah, j would have to be positive, whereas k is negative. Yeah, you have -k, but I don't have a negative anywhere in here. I'd have to have a negative out front here, -k. Okay, but this is negative, right? So k, I have to keep -k here. So that was where I'm missing. I had to keep my negative sign here. So in order to get me s of -7, right, would equate to s of 0. Index 0. K is negative in the definition. Yeah. Exactly. Yeah, exactly. It's defined as negative. So that's why it's negative here. Plus the string value would give you the positive. Okay, so you just take your negative index, assuming that that's what you're provided. You just add the total string value or the length of the string to that to get to your positive index. That's all it means, right? So if I was given the -7th index, which is the first value in the string, if I wanted to convert that to the positive index, I would just have to add n to it. If I was at, if I was at, let's say C, which is the second index, right? 0, 1, 2. If I was at, now let's say this is negative, so negative 1, negative 2, 3, 4, 5. Well, I'd have to add 7 to that, so negative 5 plus 7 would be 2. Perfect, okay, gotcha. So you would just say, um, given a negative index s of right, negative k, by adding the length of s, right, n, you get the positive so given a negative index k, add length of s to give you your positive index s of j, where s negative k, right? Where s negative k is equal to s of j. Thanks for stopping in, She Slice. Appreciate you coming in and giving the words of encouragement and providing the input. Awesome. Thanks for your help, man. Have a good night. All right. So given a negative index, s of k, s negative k, add length of s, in this case n, cool, that was that one. So r 1.9 key dash pi. Nice. Cruising here. Alright, what parameters should be sent to the range constructor to produce ranges with the value of 50, 60, 70, and 80? So let's just example is equal to we will say range, so this is where we'll put it. So we'll say we want to go to 50 to 50 to 90, and we want to go by 10, right? And we want to, let's just print the example. Okay, so if we clear this and run this program, no, we get just range. So what if I just print that? No, I just get the range object. So if I wanted to print an integer, I want to print these. I'll print a list. No. What am I doing wrong here? So if I want start on 50, end on 90, and skip every 10. And it responds with a range object. So if I say if you just say range 50, this will just give you range 50, right? You say print range 50. Yeah, it gives you 0 to 50. So if I want to print the length of range 50, that gives you 4 values within the length. So it gives you 50, 60, 70, 80. Okay, so it's doing it appropriately. It's getting the 4 values. So do I just want to list rather? Yeah. Okay, so you print out the list of values for the range object provided. So you would say range 50 start is equal to 50, right? We'll say start is equal to 50, stop is equal to 90, step is equal to 10. And we'll put in here start, stop, and step, right? So and to do this, you have to say, right, start at 50, end at 90, and skip and step every 10 integers. Exclusive. Right? So you start at 50, end at 90, exclusive, and skip every 10. So it's going to skip over it's not going to include the 90 here. So this will save this as example is equal to this, print example prob 1. Let's do that like so. Okay, we want to list prob 1. Right. Cool. Convert So that was problem 1.9. Okay, what parameter should be sent to the range constructor to produce a range of the values of 8, 6, 4, 2, 0, -2, -4, -6, -8? Okay, so yeah, this one doesn't seem that difficult. Let's just copy it over. Paste that here. Okay, so we would want to do range object is equal to range. We want to start at 8, stop at -8, skip 2, right? Print the list range object. No. So be 10, 15. Huh. So you can do -10, you can do 8, or -8, 10, 2, right? That would give me that. But I want to get the inverse. Um, hmm. How can I reverse the range object? I could just reverse the list, right? Oh, you can use negative steps? Ah, okay, so you can use negative steps. I didn't know that. Which means you have to inverse the parameters of the start. Okay, so in order to start is going to equal 8. Stop is going to equal -10. And step is going to equal to 2, right? start at 8, end at -10. Step every. Cool. Right. Okay, cool. There was 1.10. R 1.11 point. Cool. Demonstrate how to use Python's list comprehension syntax to produce the list 1, 2, 4, 8, 6, 32, 64, 128, 256. 1, 2, 4, 8. So we're just squaring. No, multiplying by 2. Okay, so we're multiplying by 2 here. For every value in the list. So, we'll just say dummy. Well, dummy variable is equal to, so we want a list comprehension. Right. So what do we want to do, to our values in the range? So we want to multiply the value by 2. So value by 2 for value in range of 1 to 256 plus 1. Right. So then if we just print dummy, this should give us all the same values, right? No. I'm gonna multiply. No, okay, so I'm looking at this wrong. So we don't want to multiply every value by 2. 2, 4, 6, 8, 10, 12, 14. This just gives us every. Right. We want to produce this list. Oh, I don't know. Here we go. Okay, think, Mike. Think. Okay, so if we want to get a list comprehension, we want to. Two 56, 24. Okay, so sorry, my brain's not working here. Demonstrate how to use Python's list comprehension syntax to produce the following list. Okay, so we want 1, 2, 4, 8. I'm going to take the value. Produce a list with that. So how could I produce a list with just these values? Right, if I just want that value multiplied by 2. Right, 16 times 2 is 32, 32 times 2 is 64, times 2 times 2 times 2. So value times 2. So if I did 0 here, this would produce me a list from 0 to starting at 0, 2. So no. Oh boy. Okay, so how would we produce this list? The value times 2. $256. Let me see here. Divided by 4. Are these just all the factors? Yeah, so these are just all the factors. Um, 0 to 256. Hello to those that are in here. I'm just studying this data structures and algorithms in Python book. I'm just working through the Python primers in chapter 1 here. I'm on R111. I'm currently trying to figure out how to produce this list where we're multiplying n, or the integer, by 2 every time to produce the next value. So if we start on 1, right, from starting on 1, we want to do 1 times value would be 1. No, so I don't want to multiply by 2 for all the values up to 256. No, I don't want to do it up to 256. That's the problem here. I want to do it anyone have any ideas out there? So it's definitely factors, right? So value for value in range of 0 to 256 plus 1 if value modulo 0 is equal modulo 2 is equal to 0, right? So if it's a factor, so just give me all the even numbers. So I don't want to get all the even numbers in this, right? That would produce me all the even numbers up to 256. I don't want that. I want the factors oh, so we want 1, so this doesn't work. So we're not finding a modulo. What kind of mathematical operation do you want to perform on this value? I feel like I'm way overthinking this. Go back here. Okay, so factors. Yeah, I did this one already. It's not that. It's not factors. It's not value times value, right? This would provide me 1, 4, 9, 16. So that would print me the square of every value. I don't want the square. I just want 1, 2, 4. So we need to index into the previous, so value times value index I for so we want to multiply the values together at index I ugh I think of this. So we want to multiply the two values together at the current position to get the next value. So we need to. I don't know why I can't think of this right now. I'm just struggling. So we need to multiply both values. We'd have to go back into the index, save this one, and then multiply it by the current value we're on. So, okay, I'm going to first do it with just demonstrate how to use Python's list converts produce. So 1, 2, 4, 8, 16, 32. How can we produce this list? So dummy list. Okay, stop doing that. Dummy list is equal to list comprehension, right? We have a list comprehension. Not sure why it just gave us balloons. We're not accomplishing anything here. Okay, list comprehension. So for value in range of 1 to 256 plus 1. What do we want to do to those values? We want to add them to the list if they are factors of 256. We want to include the value so this will include every value in the range from 1 to 256. Yes. Okay, now I only want to include the values if I want to include the value if it is a factor of 256. (256) mod value is equal to 0. Right? So if 256 divided by that value has no remainder, we want to include it. And that's how we get it. Okay, gotcha. So I was on the right track with thinking of the factors. It definitely was factors, right? But I didn't know. I was trying to put the statement up here at the beginning when I really just needed to check here. So what this basically says is in order to recreate this list here, we need, so we'll just say, I need a new variable name. We'll say, recreated list, whatever. It's a stupid name, but recreated list, right? So we're just going to use a list comprehension method here, right? Using Python's list comprehensions. So we're going to generate a list, and we're going to use this terminology inside the list. So, we're going to include the value in the list. Where are we getting these values from? For every value in the range of 1 to 256 plus 1. 256 is not included, so we want to include it, so we need to go one higher. So include every value in the range of 256 or 1 to 256, right, in this list. Do I even need to say for value. Yeah, I do need to see value. Okay. Um, if 256 modulo that value is equal to 0. So if you divide 256 by that value, each one that we loop through in this range, and it has no remainder, that means it is a factor, and we want to include it in the list comprehension here. And then I just print the list here. So that's how we get each factor: 1, 2, 4, 8, 16, 32, 64, 128, and 256 in the list. So awesome. If you guys are watching and joining, thank you for coming along so far. I appreciate you joining in. Feel free to follow along to the channel, and so you can communicate and stay up to date on my studying. And I'm going to be working through this book, Data Structures and Algorithms in Python, as well as I picked up this new book, not new book, but new to me, Python Machine Learning. I also recently picked up this weekend Fluent Python. Both got them secondhand, so good for the environment, but also wanted to get hard copies of these. I got a lot of reading to do, but we already completed a Python crash course on this channel, and so that's where I've gotten this knowledge so far. And now I'm working on the PDF version of the Data Structures and Algorithms, but on the side I'll be working on these other books. So feel free to follow along to the channel if you want to see all that content over the next coming weeks and months and whatever, as long as I'm learning this. All right, so next problem. One last problem and we're done with the R's. Okay, finally. So R 1.12 key dash point by. Okay, right. Cool, so I'll go here, copy this guy. Paste it. So Python's random module includes a function choice data that returns a random element from a non-empty sequence. The random module includes a more basic function randrange with parameterization similar to the built-in range function that returns a random choice from the given range. Using only randrange function, implement your own version of the choice function. Okay, so Python's random module includes a function choice that returns a random element from a non-empty sequence. Create your own version using just randrange. Okay, so we want to import random, right? And then we need to say, so we'll say def choice. Choice recreated, which takes in a parameter data. So we need to say for choice data. So we need to use the random range. So we need to provide a random number. The book would take you a while. Try to learn by starting with your problem. Use your logic, look up the solution, and you can get better. Gotcha. I don't really have a problem right now, Relu. I'm just kind of learning just to learn. So just kind of reading for fun and working through these for the fun of it. And, so that's why I'm kind of doing these, practice problems, because they don't really have any application to anything I'm doing, but besides just learn the choice function here. We need to, the user is going to provide a data point, and that data point is going to be user, so the user range is equal to 0, 0, Vismax says, "How old are you?" I am 25. How old are you guys? Um, so we want to use the rand range function to make your own version of choice. So it's going to pull a random number from this data. So if I give it recreate choice, so it'd be like a list goes in here, right? So this would be like a list. So it's going to pull a random data point from our list. So for value in data, or we'll just say we want to return a random rand range, right? We want to return rand range of zero to data. 0 to data. So this would be given that they provide an integer, right? So we don't want to, if it would be 0 to an integer, rand range. So 0 to list. No, we don't want this would not work. So that returns a random element from a non-empty sequence. The random module includes more basic function random range, similar to the built-in range function. Return a random choice from the given range. Using only the random range function, implement your own version of the choice function. So if the choice takes in a sequence, so for value in data, right? So for every value, now we don't want to iterate through every value in the data list. We want to provide a random element from that list. So how could we do that with just random choice of the data list, right? Rand range. So you would select a random number of the data, right? So you just return a random number from range of data. This takes in an int, start, stop, step. So I wouldn't want to directly input the list here, right? This would need to be the starting value. So this would be data index 0, right? Start, stop, data -1, right? Stop on -1. So provide a random choice from the first index to the last index of this data list that you provided. Now we don't want to include this last one. So I think that's already +1, right? So data index +1. So if I were to then print the choice recreated function and provide it with, if I did list of 10, right, this should provide me a random number. It's not iterable. So rather than using the, so this says int object is not iterable. List 10. Okay, so I can't, oh, I'd have to put like range 10, right? Right, so if I wanted to do the range 10, that would give me a random number like 7. Right, okay, perfect. Okay, that works. But I could just say, easier than this, I could just say the length of data, right? Because this would provide me all of the possible values in the length. So if I did length of data, right, that would provide me just the length of the list and give me a random number from the length of the list. But I don't want a random number from the length of the list. I want a random number from the data list that they supplied, right? Because if I did a random number of the length of the list, well, let's just say my list, right? Let's just do it for example. Let's just say dummy list, right, is equal to 1, 6, 4, 9, 3, 2, right? Well, I don't want the length of this list. I want a random value from this data set, right, Raylu? So I wouldn't want to provide the length because that would just give me 1, 2, 3, 4, 5, 6 and give me a random number between 1 and 6. Well, I want a random value from this list. No, the length of the list is just given the loop of the size to iterate. No, the length of the list is just giving the loop the size to iterate to. So if I do dummy list, no, because this won't work either because so it returns a random element from a non-empty sequence. Random eligible, reach more basic. A random choice from a given range. Right, this gives me a random choice from a given range of the length of the list. Use your own. So choice returns a random element from a non-empty sequence. So like if I did random, so what happens if I do, let me just go like this and comment this out and say if I just do print random dot choice on right, my rd dot choice, I'm gonna keep my random actually so people can understand. Random dot choice dummy list, right? What if I just do, if I do that, that should give me a random choice from this list every time. 3, 6, 2, 1, 1, 3, 9, 2, 4. Okay, gotcha. So if I'm recreating the choice function, I need to select a random int value from the list provided. And if I'm using random range, that just tells me select some random element from a list, a range of elements. Hey Vash, thanks for joining. Good to see you again. So I'm currently trying to solve R1.12 random index. Random index data. Random index equals rand range length of data. Okay. Oh, I got you. Okay, so what you would do is you would say you would get a random index using the random range, and then you would use that random index to select a random object or iteration of your list, right, or place in your list. Um, so we would take in, let's do so choice recreated, right? So we would do random dot rand range from the length of data, right? So this would give us a random index value, right? We would get some random range from the data. It doesn't have to be a list, actually. It can be like a range value. So we'd get some random index. OJ Akanbi says, hello, OJ, thanks for commenting. He says, have you tried treating it as the normal range function, like range 0 length list? The problem specifically is asking us to use the random range function. But yeah. So built in using only random function range function, implement your own version of choice. So we get a random index value, and then we return the data point, right, from our list that is at that random index value. Now, this seems, I don't know why I was thinking about it the other way. I was going, yeah, because I was trying to use the random range to get a random range value of our list. I was starting on 0 and going to here, right? But this value could only be 1 to 2, so that's why I was doing it wrong, because it wouldn't include anything above 1 and 2, right? So that's why I have to do it like this, if that makes any sense. Yeah, so yeah, OJ, I think we're trying to use the random, we have to use the rand range. I mean, we could treat it, right, 0 to the length of the data, but, right, if we could say 0 length of data here, um, but uh, length of data just suffices, I believe, as it does with the range, it's like the same range function as you had said. So then if we go ahead and do print choice recreated on our dummy list, right? We should just get a random value from this 9, 6, 4, 2, 6, 1, 6, 2. Exactly, okay. So Relu says your first approach is right as well, but in the function you included list, so you raised an error. Oh, really? Let me go ahead and I'm gonna see something. I want to see how that would look actually. So pardon me real quick. Let me go ahead and copy this, paste it here, and then I'm gonna command. Oh no, no I don't. Dang it. Um. Okay, I'll remember this. So I want to go back to that approach we were doing before then and see why I was getting an error. The data is 0. No, see, I don't think this would have worked, Raylu, because like I said before, this is specifically getting the range value from the first index value, which is 1, and the range of the last one of -1. So it'd actually be +1. The range. So it would try, I guess that's why it wouldn't work. I can't try to get from 0. So I have to go be like this. It'd have to be -1 because I can't go +1 from -1. That would just give me 0 again, right? So I wouldn't be getting any range. But if I did it like this, right, this literally means this number right here. So I would only be getting a random range value from 1 to 2. I wouldn't be getting a random index of the whole list. So this would not work. That's what I was saying earlier, if that makes sense, Raylu. So let me go back here the way I had before. Yeah, it's an index error. Exactly, exactly. It would not work because I was trying, when I had the +1 out here, this is the same thing essentially as that other problem I worked on up here, right? This exact problem where we showed that just by adding in the length of the list, you you create the inverse index or whatever, right? So this right here was just adding in that, you know, that inverse, and this right here is exactly the same as this point here. So I was only creating a range from the first index to the first index, and that wasn't working. And then if I just remove the 1, well, this was only creating it from 1 to 2 because, well, if I put in a 9 here, it would be 1 to 9 or whatever it be. But in this case, I would have a bug as well, so that wouldn't work. So what I would need to do is I would, right, we're not indexing over a list. We're just over some data, that's can be a non-empty sequence. What we're going to do is we're going to get a random index value by using the random dot rand range and using the length of our data list, right? That we can get a random index, and then we can return the data point at that random index, to get a random number or in our sequence. So then if we do this and then we print the choice recreated, and of the dummy list, right? And then if we clear this out and then run this, we get just random integers every single time from our list. So perfect. So I appreciate you guys for that help. So feel free to follow along to the channel if you like interacting with me and doing these practice problems and learning. Got a bunch of books here that I'm going to be going over, reading through over the course of the next few weeks, making videos on, live streaming pretty much almost every night. I try to during the week, and then I kind of take some breaks on the weekends. But yeah, would love to have you guys here more often when I stream. Appreciate the help, and it's a lot of fun when we get community involved. I've got a Discord for people to join if they want to chat offline. You can also check out the task tracker project that I've created. It's a intuitive but basic task tracker application that you can use to track tasks via due dates and priorities, and tasks are auto updated and saved via file IO. It all works accordingly. It's on my GitHub and the link in the description. So check that out. Hello, Kerwin. Thanks for joining. Appreciate you coming in. Good to see you. All right, so that is awesome, guys. Um, we have completed all of the reinforcement problems within uh, the exercises of chapter one. So I really wanted to complete these because these would give us a solid foundation going forward into data structures and algorithms going forward. So now these ones are a little bit more creative in the fact that they have you write like pseudocode, things like that. So I think I'm gonna skip these for now. I might work on these another time, but I'm going to just write a short program rather than takes two arrays, a and b, in length of n, storing int values, and returns the dot product of a and b. That is, it returns an array c length n such as a ci and ai as bi for I0. Oh boy, these look a little harder than I thought, actually. Should we do these? Do you guys want to do these? Should we work on them? So this says write pseudocode description for a function that reverses a list of n integers so that the numbers are listed in the opposite order that they were before, and compare this method to the equivalent Python function for doing the same thing. Right, yeah, so like you could just append each new value as you're iterating through at index point 0. So it appends at the start rather than the end. That's how you solve that one, I guess, right? Write a short Python function that takes a sequence of integer values and determines that if there's a distinct pair of numbers in the sequence whose product is odd. So these ones are kind of like just brain kind of tweezers. Just to, do you guys want to do them? Somebody give me some input. Should we do these or should we move on into reading and chapter 2? I'd like to know. What do you guys think? Kerwin asked me, how much in Python did you know before creating the task program, like up to objects or inheritance? Yeah, I took Python CS50P offered through CS50, and I completed the final project on that. I used a lot of resources on that final project to learn, and then my task tracker project I was actually able to write pretty much all on my own with just some help from the stream and maybe a couple of little things to look up about how to researching some functions. But I was able to kind of write it all from memory and just practice over and over again, trial and error, and I learned a lot that way. Um, but I know kind of just the general basics, I guess. I I don't really know. I got to like inheritance and things like that. I didn't really implement too much inheritance into my programs or if any. Um, but yeah, like file IO. We got to at the end of CS50. You talk about what do you talk about? Well, the last lecture they give you like all the tidbits like list comprehensions and stuff. Um, I can't really remember. It's been a little bit. Yeah, so you don't really once you get to object oriented programming, that at that point I felt like I could kind of branch out and start to make my own kind of stuff. Like I once I figured out how to represent real world objects as code, then I was like, okay, now I can finally start taking things from my real world and having them be stored as things. Like it just clicked when I learned that. So appreciate the questions and comments. Thanks so much, Kerwin. Whoever's giving me the hearts, I really appreciate it. All right, so these would be fun to do. Would be cool to do. So, um, projects. So let's have these projects. Write a Python program that outputs all the possible strings formed using the characters cat and dog exactly once. Possible strings formed. greater than 2. So these kind of just have you do like, I guess they're kind of fun. So I do kind of want to move on. I've been on this for a couple of days now, so I might come back to these and do like maybe one a day as warm up to kind of as I'm reading the next chapter to kind of break things up. So I think that would be a good idea. But let's go ahead and move on here to chapter 2, which is object oriented programming. So this might be a little bit of review here, but it might also be good for breaking down more in depth things. So this will be good for Kerwin if you were asking about the object orientedness here. This is it here. So goals, principles, and patterns. So as the name implies, the main actors in the object-oriented paradigm are called objects. Each object is an instance of a class. Each class presents to the outside world a concise and consistent view of the objects that are instances of this class. Without going into too much unnecessary detail or giving others access to the inner workings of the objects, the class definition typically specifies instance variables, also known as data members. The object contains, as well as the methods, also known as member functions, that the object can execute. This view of computing is intended to fulfill several goals and incorporate several design principles which we can discuss in this chapter. Cool. So yeah, when you create objects, they have attributes. Typically specifies instance variables that the object contains, and as well as methods that the object can execute. Right. So you have like a hammer. You can have an object method that says swing hammer. Boom. You can have a instance variable that says that this hammer is blue, right? Things like that. From my understanding. Robustness. Every good programmer wants to develop software that is correct, which means that a program produces the right output for all the anticipated inputs that a program's application. In addition, we want software to be robust, that is, capable of handling unexpected inputs that are not explicitly defined for its application. For example, if a program is expecting a positive integer, perhaps representing the price of an item, and instead is given a negative integer, then the program should be able to recover gracefully from this error. More importantly, in life-critical applications where a software error can lead to injury or loss of life, software that is not robust could be deadly. This point was driven home in the late 1980s. Yeah, at this point, I listened to a lecture by Uncle Bob. If you listen to his Clean Code TED Talk, he talks about how he thinks that in the future, government legislators are going to crack down on software engineers and developers because they've kind of been given free ride and free reins to program, and given the benefit of the doubt that their programs are safe and things along those lines. And there hasn't been like too much regulation, broad spectrum. Um, Now, like things like cars and stuff run software, so if you have bad programs in cars, you can cause crashes and deaths. So I think that his theory, and which makes sense, that in the upcoming years that you might see a lot more government agencies crack down on code, and his whole thing is like preventative measures of implementing guidelines and of writing clean code now, and adhering and abiding to those rules personally, like those personal guidelines, internal guidelines for the community, so that we don't ever get down to that point where the government gets involved. So that's kind of like his fear, I guess, with it, which it makes sense. So, okay. This point was driven home in the late 1980s in accidents involving Therac 25, a radiation therapy machine, which severely overdosed 6 patients. Yeah. See, like, if you just have incorrect software, you can just kill people. It's crazy. Between 85 and 87, some of whom died from complications resulting from their radiation overdose. All 6 accidents were traced to software errors. Wow. Probably got a big pay lawsuit right there. Adaptability. Modern software applications such as web browsers and internet search engines typically involve large programs that are used for many years. Software, therefore, needs to be able to evolve over time in response to changing conditions in its environment. Thus, another important goal of quality software is that it achieves adaptability. also called evolvability. Related to this concept is portability, which is the ability of software to run with minimal change on different hardware and operating system platforms. An advantage of writing software in Python is the portability provided by the language itself. All right, reusability. Going hand in hand with adaptability in the desire that software be reusable, that is, the same code should be usable as a component of different systems in various applications. Developing quality software can be expensive enterprise, and its cost can be offset somewhat if the software is designed in a way that makes it easily reusable in future applications. Such reuse should be done with care, however, for one of the major sources of software errors in the Therac 25 came from inappropriate reuse of the Therac 20 software, which was not object oriented and not designed for the hardware platform used with the Therac 25. Interesting. Design principles. Chief among the principles of the object oriented approach, which is intended to facilitate the goals outlined above, are the following: modularity, abstraction, encapsulation. Cool. Modularity. Modern software systems typically consist of several different components that must interact correctly in order for the entire system to work properly. Keeping those interactions straight requires that these different components be well organized. Modularity refers to an organizing principle in which different components of software systems are divided into separate functional units. In a real-world analogy, a house or apartment can be viewed as consisting of several interacting units: electrical, heating and cooling, plumbing, and structural. Rather than viewing these systems as one giant jumble of wires, vents, pipes, and boards, the organized architect designed a house or apartment will view them as separate modules that interact in well-defined ways. In so doing, he or she is using modularity to bring a clarity of thought that provides a natural way of organizing functions to distinct manageable units. So kind of a lot of information there, but that basically says that we want to keep things distinct and separate so that as they change, they're not all intertwined and you have to change a bunch of things. In like manner, using modularity in software systems can also provide powerful organizing framework that brings clarity to an implementation. Emilio, hello, thanks for joining. I appreciate you leaving a comment. Feel free to follow along the channel so we can interact some more. I'd love to chat with you some more on later dates. But he says, hey there, what's your motivation for learning Python? I am I have a degree in human biology and chemistry, and I am a formulation chemist for a biotech company. And I have a lot of instances where I could use software to automate processes, do a lot of math for me that I do on a daily basis, for formulating different matrices and stuff like that. So I kind of wanted to do that. I started making some simple programs, learning some classes, and then I just started reading some books and kept going. So I'm just kind of expanding my knowledge further and further and further, little by little. And I just thought I would capture it on stream, share it as I go. So if you're interested in that, please follow along. All right, so back to this. In like manner, using modularity in software systems can also provide a powerful organizing framework that brings clarity to an implementation. In Python, we already have seen that a module is a collection of closely related functions and classes that are defined together in a single file or source code, right? You can import random, right? Has all these methods in it. You can import the math module, which provides definitions for key mathematical constants and functions, and the OS module, which provides support for interacting with the operating system. The use of modularity helps support the goals listed in section 2.1.1. Robustness is greatly increased because it's easier to test and debug separate components before they're integrated into larger software systems. If you can test a bunch of different functions rather than one giant function, you can find probably more nuances, right? Easier. The structure imposed by modular also helps enable software usability. If software modules are written in a general way, the modules can be reused when related need arise in other contexts. This is particularly relevant in studying data structures, which can typically be designed with sufficient abstraction and generality to be reused in many applications. Cool. Abstraction. The notion of abstraction is to distill a complicated system down to its most fundamental parts. Typically, describing the parts of a system involves naming them and explaining their functionality. Applying the abstraction paradigm to the design of data structures gives rise to the abstract data types, ADTs. An ADT is a mathematical model of a data structure. Okay, ADT is a mathematical model of a data structure that specifies the type of data stored, the operations supported on them, and the types of parameters of the operations. An ADT specifies what an operation does and how it does it. We will typically refer to a collective set of behaviors supported by ADT as its public interface. Okay. All right. As programming language, Python provides a great deal of latitude in regard to the specification of an interface. Sorry. Python has a tradition of treating abstractions implicitly, using a mechanism known as duck typing. As an interpreted and dynamically typed language, there is no compile time checking of data types in Python and no formal requirement for declarations of abstract base classes. Instead, programmers assume that an object supports a set of known behaviors, with this interpreter raising a runtime error if those assumptions fail. The description of this as duck typing comes from an adage attributed to the poet James Whitcomb Riley, stating that when I see a bird that walks like a duck and swims like a duck and quacks like a duck, I call that bird a duck. More formally, Python supports abstract data types, ADTs, using a mechanism known as an abstract base class, an ABC. Oh, here we go. All these acronyms are coming getting crazy. An abstract base class cannot be instantiated. You cannot directly create an instance of that class, right? It can't be instantiated, but it defines one or more common methods that all implementations of the abstraction must have. An ABC, or an abstract base class, is realized by one or more concrete classes that inherit from the abstract base class while providing implementations for those methods declared by the abstract base class. Okay. Python's ABC module provides formal support for ABCs, although we omit such declarations for simplicity. We will make use of several existing abstract-based classes coming from Python's collections module, which includes definitions of several common data structures, ADTs, and concrete implementations of some of those abstractions. Interesting. Encapsulation. Another important principle of object-oriented design is encapsulation. Different components of a software system should not reveal the internal details of their respective implementations. One of the main advantages of encapsulation is that it gives one programmer freedom to implement the details of a component without concern that other programmers will be writing code that intricately depends on those internal decisions. The only constraint on the programmer of a component is to maintain the public interface of the component, as other programmers will be writing code that depends on the interface. Encapsulation yields robustness and adaptability, for it allows the implementation details of parts of a program to change without adversely affecting other parts, thereby making it easier to fix bugs or add new functionality. Throughout this book, we will adhere to the principles of encapsulation, making clear which aspects of data structures are assumed to be public and which are assumed to be internal details. With that said, Python provides only loose support for encapsulation. By convention, names of members of a class, both data members and member functions that start with single underscores, characters, underscore secret, are assumed to be non-public and should not be relied upon. Those conventions are reinforced by the internal omission of those members that automatically generated documentation. Okay. A lot of info there. Design patterns. Object-oriented design facilitates reusable, robust, and adaptable software. Designing good code takes more than simply understanding object-oriented methodologies, however. It requires the effective use of object-oriented design techniques. Computing researchers and practitioners have developed a variety of organizational concepts and methodologies for designing quality object-oriented software that is concise, correct, and reusable. Of special relevance to this book is a concept of design pattern, which describes a solution of a typical software design problem. A pattern provides a general template for a solution that can be applied in many different situations. It describes the main elements of a solution in an abstract way that can be specialized for a specific problem at hand. It consists of a name which identifies the pattern, a context which describes the scenarios for which this pattern can be applied, a template which describes how this pattern is applied, and a result which describes an analyzes what the pattern produces. We present several design patterns in this book, and we show how they can be consistently applied to implementations of data structures and algorithms. These design patterns fall into two groups: patterns for solving algorithm design problems and patterns for solving software engineering problems. The algorithm design patterns we discuss include the following: recursion, amortization, divide and conquer, prudent search, brute force, dynamic programming, the greedy method. So these are algorithm design patterns. Okay. Likewise, software engineering design patterns we discuss include iterator, adapter, position, composition, template, locator, factory. Okay. Rather than explain each of these concepts here, however, we introduce them throughout the text as noted above. For each pattern, be it for algorithm engineering or software engineering, we explain its general use and we illustrate it with at least one concrete example. Cool. 2.2 Software development. Traditional software development involves several phases. Hello to those that are here. Really quick, I'm just reading out of Data Structures and Algorithms in Python, the PDF form found online. We are in Chapter 2. We just completed Chapter 1 and completed all these R problems that it provided, all 12 of them. And I'll be providing this in a repo as I go throughout this studying. And feel free to follow along the channel if you want to study along with me. Alright, so the three major steps are design, implementation, testing, and debugging. In this section, we briefly discuss the roles in each phases, and we introduce several good practices for programming in Python, including coding style, naming conventions, and formal documentation and unit testing. Design. So for object-oriented programming, the design step is perhaps the most important phase in the process for developing software. For it is the design step that we decide how to divide the workings of our programs into classes. We decide how these classes will interact, what data will store, what data each will store, and what actions each will perform. Indeed, one of the main challenges that beginning programmers face is deciding what classes to define to do the work for the program. While general prescriptions are hard to come by, there are some rules of thumb we can apply when determining how to design our classes. Responsibilities. Divide the work into different actors, which each with a different responsibility. Try to describe responsibility using action verbs. These actors will form the classes for the program. Independence. Define the work for each class to be as independent from other classes as possible. Subdivide responsibilities each between classes so that each class has autonomy over some aspects of the program. Give data as instance variables to the class that has jurisdiction over the actions that require access to this data. Behaviors. Define the behaviors for each class carefully and precisely so that the consequences of each action performed by the class will be well understood by other classes that interact with it. Okay, these behaviors will define the methods of the class performs and set the behaviors for the class that are interfaced to the class. Okay, as these form the means of the other pieces of code or interact with the objects of the class. Defining the classes together with the instance variables and methods are key to the design of object-oriented program. A good programmer will naturally develop greater skill in performing these tasks over time as experience teaches him or her to notice patterns and requirements of the program matches that he or she has seen before. Cool. A common tool for developing an initial high-level design for a project is the use of CRC cards, Class Responsibility Collaborator. Cards are simple index cards that subdivide the work required for a program. The main idea behind this tool is to have each card represent a component, which will ultimately become a class in the program. We write the name of each component on the top of an index card. On the left-hand side of the card, we begin by writing the responsibilities for each component, for this component. On the right-hand side, we list the collaborators for this component. That is, the other objects that this component will have to interact with to perform its duties. So this class, credit card, fields, customer, balance, bank, count, limit, behaviors, get customer. Okay, so you have a class credit card, you have these instance variables, right, that are associated with each credit card. Each credit card has a balance, has a limit, has an account, has a bank, has a customer, right? These like self underscore customer, right? Whereas the behaviors are these methods associated where you can get customer, you can get bank, you can get account, make payment. Okay, gotcha. So these cards help you kind of break things down, and then you can go ahead and program rather than keeping things in your head. The design process iterates through an action/actor cycle that we first identify an action. That is a responsibility, and we determine an actor that is a component that is best suited to perform the action. The design is complete when we have assigned all actions to actors. In using index cards for this process rather than large pieces of paper, we are relying on the fact that each component should have a small set of responsibilities and collaborators. Enforcing this rule helps us keep the individual classes manageable. So you don't want to add in a ton of stuff here because you need to keep things pretty concise. And if stuff starts overlapping, well, you can create a new class. Things like that. Okay, as the designs take form, a standard approach to explain the document and design is the use of the UML, Unified Modeling Language diagrams, to express the organization of a program. UML diagrams are a standard visualization notation to express the object-oriented software designs. Several computer-aided tools are available to build UML diagrams. One type of UML figure is known as a class diagram. An example of such diagram is given in figure 2.3 for the class that represents a customer's credit card. The diagram has three portions. The first designating the name of the class, the second designating the recommended instance variables, and the third designating the recommended methods. Yep, exactly. The second, in section 2.2.3, we discuss our naming conventions. In section 2.3.1, we provide the complete implementation of Python credit card class based on this design. Nice. Cool. Right? As we said before, these are all the instance variables that are associated with a class of a credit card, and these are all the methods that that class can perform to make certain various functions happen. Pseudocode. As an intermediate step before the implementation of a design, programmers are often asked to describe algorithms in a way that is intended for human eyes only. Such descriptions are called pseudocode. Pseudocode is not a computer program, but is more structured than a usual prose. It is a mixture of natural language and high-level programming constructs that describe the main ideas behind a generic implementation of a data structure or algorithm. Because pseudocode is designed for a human reader, not a computer, we can communicate high-level ideas without being burdened with low-level implementation details. At the same time, we should not gloss over important steps. Like many forms of human communication, finding the right balance is an important skill that is refined throughout the process. In this book, we rely on the pseudocode style that we hope will be evident to Python programmers. Yet with a mix of mathematical notations and English prose. For example, we might use the phrase indicate an error rather than a formal raise statement. Following the conventions of Python, we rely on indentation to indicate the extent of the control structures, and on an indexing notation in which entries of a sequence A with a length n are indexed from A to 0 to A to n minus 1, right? However, we choose to enclose comments with curly braces like these in our pseudocode rather than using Python's hashtag character. Gotcha. Coding style and documentation. Programmers should be made easy to read. Programs should be made easy to read and understand. Good programmers should therefore be mindful of their coding style and develop a style that communicates their important aspects of a programmer's design for both human and computers. Conventions for coding style tend to vary between different programming communities. Okay, you can look at the PEP 8. The main principles we follow, the Python blocks are typically, yeah, these are just the PEP8. I'm going to skip this. Recall that from our discussion of encapsulation and identifiers in any context that begins with a single leading underscore, underscore secret are intended to be suggest that they are only for internal use of the class or module, not a part of public interface. If use comments that add meaning to a program, explain ambiguous or confusing constructs. Inline comments are good for quick explanations that intended for Python following the hashtag character as in, yep. Multi-line block comments are good for explanation more complex code sections. In Python, these are technically multi-string literals, typically defined by the triple quotes, which have no effect on when executed. Okay, so you can use doc strings. Python provides integrated support for embedding formal documentation directly into source code using the mechanism known as docstring. Formally, any string literal that appears as first statement within the body of a module, class, or function, including a member function of a class, will be considered a docstring. By convention, those string literals should be delimited within three quotes, right? As an example, our version of the scale function from page 25 could document as follows. So scale data factor takes a docstring of multiply all entries by numeric data list by the given factor. So for j in range of the length of the list, we multiply the data of j by the factor. We're indexing the length, right? And then we take the data point at that index, we multiply it by the new factor to pretty much scale up that length of the list. Cool. It is common to use the triple quote string delimiter for a docstring even when the string fits on a single line, as it is an example above. More detailed docstrings should begin with a single line that summarizes the purpose, followed by a blank line and then further details. For example, we might more clearly document the scale function as follows. Multiply all entries of the numeric list by a given factor. So data, an instance, and then factor. Okay, gotcha. So you can provide like a heading and then give a breakdown of each individual parameter that the function takes. So a docstring is stored as a field of the module, function, or class in which it is declared. It serves as a documentation that can be retrieved in a variety of ways. For example, the command help x within the Python interpreter produces the documentation associated with the identifier object x. Okay, an internal tool named PyDoc is distributed with Python that can be used to generate formal documentation as text or web page. Guidelines for authoring useful docstrings are available at boom. In this book, we will try to present docstrings when space allows. Omitted docstrings can be found in the online version of the source code. Testing and debugging. Testing is the process of experimentally checking the correctness of a program, while debugging is the process of tracking the execution of a program and discovering the errors in it. Testing and debugging are often the most time-consuming activity in the test and development of a program. Testing. A careful test plan is an essential part of writing a program. While verifying the correctness of a program over all possible inputs is usually infeasible, we should aim at executing the program on a representative subset of inputs. At the very minimum, we should make sure that every method of a class is tested at least once method coverage. Even better, each code statement in the program should be executed at least once with a statement coverage. Programs often tend to fail on special cases of the input. Such cases need to be carefully identified and tested. For example, when the testing a method that sorts, that is, puts in order a sequence of integers, we should consider the following inputs. The sequence has 0 length, the sequence has only one element, all the elements of the sequence are the same, the sequence is already sorted, the sequence is in reverse sorted. In addition, the special inputs to the program, we should also consider special conditions for the structures used in the program. For example, if we use a Python list to store data, we should make sure the boundary cases, such as the inserting or removing at the beginning and the end of the list, are appropriately handled. While it is essential to use handcrafted test suites, it is also advantageous to run the program on a large collection of randomly generated inputs. The random module in Python provides several means for generating random numbers or for randomizing the order of collections. The dependencies among the classes and functions of the program induce a hierarchy. Namely, a component A is above component B in the hierarchy if A depends on B, such that So namely, a component A is above a component B in the hierarchy if A depends upon B, such as when A is called, function B, when such as when function A calls function B, or function B relies on a parameter that's an instance of function B. Okay, yeah, right. So there are two main testing strategies, top down, bottom up, which refers to the order in which components are tested. Top down testing proceeds from the top to the bottom of the program hierarchy. It is typically used in conjunction with stubbing, a bootstrapping technique that replaces a low level component with a stub, a replacement for the component that simulates the functionality of the original. Okay. For example, if function A calls function B to get the first line of a file, when testing A, we can replace B with a stub that returns a fixed string. Okay, so rather than using another function, right, in function B, you can just use a stub or a placeholder as the string itself that it would return. Bottom-up testing proceeds from lower level components to higher level components. For example, bottom level functions which do not invoke other functions are tested first, followed by functions that call only bottom level functions, so that before other class units, another class that depends on the former. Okay, gotcha. So this form of testing is usually described as unit testing, as the functionality of of a specific component is tested in isolation of the larger software project. If used properly, this strategy better isolates the cause of errors to the component being tested, as lower level components upon which it relies should have already been thoroughly tested, right? So if you're using bottom up testing, you first test functions that don't have any other dependency, and then start testing function. So it'd be like starting off on the branches, and then right, and then going all the way up to the main things that that use everything, and that's a unit test. Okay, Python provides several forms of support for automating testing. When a functions or classes are defined in a module, testing for that module can be embedded in the same file. The mechanism for doing so is described in 1.1, code that is shielded in a conditional storm as this. Right. Okay. So this is used for testing and stuff. Will be executed when Python is invoked directly on that module, but not when the module is imported for use in a larger software project. Gotcha. Hello to those that are here. I appreciate you joining. Just reading the data structure and algorithms in Python. Just learning about object-oriented programming in Chapter 2. I already have quite a bit of backing with object-oriented programming and some examples and some code I've written in the Task Tracker project, but just using this as a further solidification of the knowledge before we expand into actual data structures and algorithms and more deep concepts here. So the mechanism for doing so, Python provides several forms of support for automated testing. When functions or classes are defined in a module, testing for that module can be embedded in the same file. The mechanism for doing so, okay, so if you have testing in the same file, you use this, okay. It is common to put tests in such a construct to test the functionality of the function and classes specifically defined in that module. More robust support for automation of unit tests is provided in Python's unit test module. This framework allows the grouping of individual test cases into larger test suites and provides support for executing those tests and reporting or analyzing the results of those tests. As software is maintained, the act of regression testing is used, whereby all previous tests are re-executed to ensure that changes to software do not introduce new bugs. Okay, so regression testing is just to reiterate all the previous tests when changes are made so that you know that you haven't changed anything from the past. Gotcha. Debugging. All right. The simplest debugging techniques consist of using print statements to track the values of variables during the execution of a program. A problem with this approach is that eventually the print statement needed to be removed or commented out so they do not execute within software is fully released. A better approach to run is the program within a debugger. It is a specialized environment for controlling and monitoring the execution of a program. The basic functionality provided by a debugger is the insertion of breakpoints, right? You can do like this. Insert a breakpoint. within the code. When the program is executed within the debugger, it stops at each breakpoint. While the program is stopped, the current value of the variable can be inspected. The standard Python distribution includes a module PDB, which provides debugging support directly within the interpreter. Most IDEs for Python, such as IDLE, provide debugging environments with graphic user interfaces. All right, cool. So I've been streaming for about 2 hours and 37 minutes here. So I think this is a good place to stop here on page 69. We're going to stop here, and before we get into class definitions, today we went ahead and continued on and completed problems R1.4 through R1.2 out of the Python primer in chapter 1, which basically set us up for every kind of making sure that we were solid in our fundamentals of Python to go ahead and gear forward into learning more about the actual approaches to data structures and algorithms. So in the next stream tomorrow, I will be back and I will be reading more from this class definitions, and we will do a couple more of the Python primer problems as just warm up every day until we finish those from the creatives and then the project section. So please follow along to the channel if you want to interact more with me tomorrow and with my future streams. I will create videos. I will say I picked up the Fluent Python book. I will be reading this on stream live and completing the problems within inside to better solidify and really master Python as a whole. And I also will be moving on to Python machine learning after that, or maybe in the middle or whenever I see fit, as I continue working and developing a mastery in Python and in programming. And it's just a self-taught journey, so feel free to join along if that's something that interests you and you're also in the same boat. And thanks so much for watching. Feel free to check out the task tracker application that we made together and that I made on stream. It is really cool. It can track your tasks for you across multiple days and saves files for you that can be reread, and those tasks are updated and can expire as time progresses and becomes closer to your due dates. So feel free to check that out on the GitHub and check out all the other resources on the channel for studying. And I have quite a few videos about Python Crash Course on my channel, and I'm going to be continuing to create the try it yourself problems. I think that they're just really good basic beginner problems that can help someone really wrap their head around these concepts of loops, variables, functions, everything like that. So I will continue with doing the Python Crash Course try it yourself problem videos on my channel.